Recording in progress. So welcome to Lecture 8. Today will be the first day of textures. So project 6, well, actually, let me preface that. Okay, one of your project 6 environments becomes project 7, only one. Your choice. If you are completely in love with your reference from project 6, you can start looking for textures if your reference requires you to have textures. Not every object will need texturing. Texturing is sometimes misunderstood. Only 2 objects in your close-up need to have Substance Painter files with them. Okay, you need to do those in Substance Painter. All the others you can do in Photoshop. You can download images off the internet, use photo images as is, because sometimes you don't need to do much to an image if it is giving you what you want compared to your reference. Does that make sense? So let me unfreeze my screen for you guys. So, as I said, one of your project 6 environments becomes project 7, only one. So today we're going to be dealing with basic maps, file mapping methods. There's 2 different main file mapping methods that we can use. One is called texture. It's basically just using UVs, and the other is called projection. Projections will basically allow you to take a 2-dimensional flat image and put it on a 3-dimensional object, moving it around where you need it. We'll get to that on Monday. Tony Bagsby will be doing that with you guys. So, but today we're just going to go over the basic maps. And like I said, not every image, or sorry, not every object needs a texture. Things like glass. Do you need a texture to describe that? No, because we did it already with the glass lecture. How about metal? It depends. You might if there's thumbprints, worn areas, rust, but if it's just a piece of metal that's kind of generic and you don't see much detail because it's far away, no, you don't. So like I said, if you are totally in love with your reference images, you don't have to change it. The good thing is in project 7, if you don't like something, it's a good time to change your reference. So if you don't like how it came out in project 6, or you don't think you can find a texture for it, or you're having trouble finding a texture, feel free to change your reference. Does that make sense? Okay. So some downloads for you guys. Lecture 6, new PowerPoint. That will be for the second half of lecture. It's basically containing the workflow for taking a brick wall and making it seamless or repeatable with very few noticeable differences. So it's a skill that you'll need for computer animation and also game art. Now, there are plenty of ways to do it. We're going to do it in Photoshop. And we're also going to generate an additional map out of there. So besides making a diffuse map or a color map inside Photoshop, we're also going to be making a bump map. So we have Photoshop files for you to download, which is all part of that little package. And we have a new set of templates for Project 7. And we have a couple of logos for you, because you will be using one of those logos to project, do a projection in Maya in 3D. So you can do projections in Substance, but we need you to be able to do one in Maya. And also on Monday, we're going to be talking about Maya's layering system. It's called a layer texture, and it allows you to build up layers just like, sort of like you can in Photoshop and or Substance. It's not as robust. It's not as elegant. It works though. All right, so don't forget Sunday from 1 to 9. 1 to 5 will be lecture, 5 to 9 will be lab on Sunday. Tony Bagsby, who was here on Wednesday, he will be doing the Substance Painter portion of texturing. So for that, you guys will be home. So if you have your tablets around, drag them in, use them, because it's going to be a lot easier to play around in Substance using a tablet and pen than it is a mouse. Mouse is kind of like using a bar of soap. Only it doesn't smell as nice. All right, so Discord office hours next week will be Tuesday and Thursday. Frank and Ari or Ari will be doing the Zoom Open Lab next week for campus and online students, 1 to 5 p.m. Remember, all Full Sail times are in Eastern Standard Time. For anybody watching this video who is in another time zone. So today, basic maps, and our basic maps will be the diffuse or sometimes called base color, specular maps for reflectivity, roughness, pretty self-explanatory to control roughness. And then bump maps is what we use in software rendering in our class. So bump maps are very simple height maps. And you'll find that a lot of these maps, spec, roughness, height maps, all share one unique characteristic. And we'll talk about that when we get to talking about the individual maps. So file mapping methods, today it's just going to be normal, average, garden variety texture mapping. Using UVs. Gives us some two-dimensional control. We have, when we put these maps on, we have a little bit of functionality as far as moving stuff around, but your UVs and how they're laid out will be key to a map applying or looking correct on your object. So there's going to be times when you take a photo texture, put it on, and it may be, rotated 180 degrees, or maybe rotated 90 degrees, or the parts of the object don't quite fit in there. And then even though your UVs are laid out, you may have to rearrange them to fit that particular texture. After break, basic Photoshop tools. All of you probably know all this stuff already in Photoshop, but just going to go over some of the basic tools, navigational things in Photoshop. And then we're going to make a simple, seamless brick texture. All right, questions, comments, everybody good? Okay. So let's talk a little bit about our basic primary map, which is going to be a diffuse or base color. Now, the need for a base color or diffuse map arises when you need to show more than one color on a single surface, or you've got a visible texture, surface detail, wood, the pattern on your desktops that you guys are working on, that kind of little noisy little black and white speckled pattern on your desktops there. All of that fabric, for example, pillows, cushions, wallpaper, flooring, our carpet, could we describe that with a single color down here? No, you would need a map to describe that because that is a visual surface detail. So color, more than one color. On a surface at a time. Texture, any kind of visual surface detail. Like I said, this happens to be a 12 by 12 vinyl floor tile. Can't describe that with a single color. All right, so base color, that's where your maps get plugged into. Once you plug a file into that base color, all of those normal color attributes that you had are now overridden by a file. When we talk about maps, that basically means you are bringing a file in that is not native to Maya usually, bringing it in from the outside. Okay, all maps should reside in the source images folder. Of your project. That is the proper location for it. Don't put them on your desktop. Don't put them in another folder somewhere else on your computer, because if you move the location of your Maya project folder or the location of those files, it will break the connection and Maya will display nothing. It'll display total black. So that part is very important. Does that make sense? Now, a lot of times when you go to bring a map in, let me clean this up a little. So more than one color at a time. So when you bring a map in, sometimes you will plop it in and find, oh, wow. I have a lot of light on that object and my texture is completely blown out. Now, if it's a solid color, all you have to do is change the value in it or, make the color a little darker to compensate for that. But when you're using a map, you don't have hue, saturation, and value to play with, right? It is a fixed set of pixels. So what you can do is adjust the base weight. The base weight is literally allowing you to adjust how much light affects that object. Remember, base, the whole base part of the material is primary visibility. It allows light to hit a surface and bounce back. When you turn off base weight, you're basically shutting that part of the material off, and light will ignore it. All right, so let me give you a very quick example of this. I'm going to take the little image that I have down there. I'm going to open up my Zen garden. All right, let me set my project. All right, so since Tony Bagsby did the lecture, I didn't do material, the glass with you guys, but I have it from last month and I'm going to use that as a springboard. So let me save as. Save as again. Because it's Maya, it's spiteful. Always make copies. All right, so let me just do a quick render just to make sure everything is visible, nothing's whacked. Like I said, it's Maya. All right, good enough. Actually, not a bad camera angle. So I have this table here in the Zen garden. If anybody's ever seen the Zen garden in real life other than the photo references, so that's a pretty worn piece of wood on that table. There's literally no reflectivity on it. Now, depends on what time of the year you take pictures. They'll come in once, maybe twice a year and refinish those, but the finish doesn't last long because it's Florida. A lot of sun, a lot of UV, and a lot of rain. So it's usually pretty diffuse. It's rough. So I went out and, well, I didn't have to look too hard because you can go to the internet and go, show me worn wood boards, texture. And, you can usually type that kind of stuff in. So when you guys are looking for textures, don't forget you want to get at least a 2K texture. 2048 by 2048 or 2048 by some height. The bigger the texture resolution, the more resolution you have, the better it will look in your render. If you take a very, very small texture, in fact, let me grab a couple really ridiculous ones. So board textures. So you can even go wooden board texture seamless. But I'm just going to go textures. All right, so what I want to find is something that is not too big as far as resolution goes. Oh, that's a perfect one. I wonder if I can download it. Oh, it is a JPEG. Okay. All right, so this would be an example of a ridiculously small texture. How big is it? Oh, let's open it up, find out. Well, actually, I didn't have to do that. I could just go get info. And here it is, 280 by 276. That is actually laughable. So let's say, for example, let me assign a new material to this table. So let's do Shift T, Arnold, shader, AI standard surface. So this one's going to be low res wood text. Now, what I want to do is plug it into the base. So in the base part of the material under color, click the little checker button for mapping, create render node. You want a 2D file. Now this goes for almost anything you want to plug into Maya. You're probably going to be using a file. A file node will allow you to plug in PNGs, JPEGs, Targas, TIFFs, EXRs, pretty much anything that Maya can read. Now, what I should do at this point is take this low-res wood texture, and let me rename that so I know exactly what it is. And I'm going to put it into my source images of my Maya project folder. So here's my Maya project folder. There's source images. You can see I got a bunch of stuff in there already. I've even got a Zen Garden folder with extra stuff. So I'm going to put it inside there. Inside your source images, you can organize with different folders, as long as they reside in your source images. So let me just drop in my low-res wood. And now, since I've set my project, if I go to get my texture, which under File, Image Name, click the folder icon, it should take you right into your project, source images, and there's my Zen Garden source images. And I want to go down to my L for low res, which is right here. Now, if you want to see your texture in the viewport, what do you have to hit? 6. Yep. Remember, 4 wireframe, 5 is shaded, 6 should be textures. So there it is. Now, it doesn't look all that bad. Let's render it out and see what it looks like. Let's kind of zoom in. Oops. Kind of zoom in here. Now, you see how blurry that is? The reason it is blurry is because we've got a small file that we've stretched to fill a bigger area. What we're doing is we're stretching those pixels to be bigger than they should be. Now, how small or how big your pixels are on your surface is called texel density. Texel density is basically, are the pixels the actual size, or have they been enlarged to force to fit a bigger area than they should? So take a small image and make it fill a big area, you're stretching that image and you're making it look pixelated because all those pixels get bigger. Does that make sense? So you can even do that inside the inside this little Maya Mac preview window. So notice when I increase the size of this, you can basically see the pixels right here. Really nasty. But when it's actual size, doesn't look that bad, right? So the same thing happens if you take a very small thumbnail, if you will, image and force it onto a big surface and you render it. So ideally, we are rendering out basically a 1K image. The reason you want 2K is because that one extra K of pixel resolution will hold up in your render. You basically want to almost have twice the resolution of what you're rendering at in order to maintain a nice, sharp looking image. You might be able to get away with a 1-to-1, but I wouldn't stick it in front of the camera because the camera doesn't lie. The camera will pick stuff up. All right, so we got that. Let me save that. Now let me take an image that I've gotten. So there's our low res. So here's another image I found. So this one is meant to be much bigger. So let's drop it in. Well, let me create a new material. And let's call this table texture. And what I'm going to do is plug that affordable texture that I found, which is much bigger. And that is going to, no, wrong one. That is going to go in right here. All right. So you can see there's a little more detail, but the problem is this is a very light colored piece of wood. And what's happening is we've got a lot of energy from the light. And basically it is just blowing out that texture, blowing out all the detail in the image. So you can see that is a 2K image, pretty much. 2000 pixels by almost 1K. Yes. If you're using Google, go to Tools. You want size large. Yep, still use large. In fact, a lot of times if you hover or just click on it, it'll tell you in here what it is. It's the Mac Preview program. You just double click on it. Now, to get the information that I got, all you have to do is click on any file and do Get Info, which is Command-I on the Mac. So here I could take this calendar, I could do Command-I. It'll tell me all kinds of information like the size, RGB, what's the color profile. It's very useful. Now, if you're in a window like this, and if you click on it, I always have mine set up so I have these panes, and you get that same information here. So that one's 14. That one's 15. too small. So at least you stand a better chance of getting something 2K. Now you could also try to search in theory, these should be 2K, but well, that one is. So that one's not bad. So it might take a little bit of work to get, you may fall in love with one that's too small. Try not to, love at first sight. Just, you want to go out a few times and make sure you're compatible. And you want to find out, hey, is this going to work? Is it the right size? Is it the kind of texture I want? All right, so let's go back and talk about the actual material part itself. So I've got my texture on there. Now, I did do a little bit of revamping of my UVs. So I don't want checker on there. There we go. So I did kind of redo my UVs based on this texture. So it laid right. What I was after is just getting the top visible part to the camera, make sure they had separate boards so it didn't look all the same. And then I took those small pieces, on the side that you can barely see, and I just tried to line them up logically wherever they made sense. All right, so having said all that, what I want to do is I want to knock down how much light my material is accepting. Right now at 1, it's accepting 100% of the sun and that pretty bright dome light I have. Now, as you can see, I got no detail. So what you want to do is start to lower the base weight little by little. So I usually like to go down like 0.9. I'll go down 1/10 of a unit. All right, so ever so slightly better. You can see at 90% of that energy, it's still really bright. So let's knock it down. Let me go down to 0.8. You can see we're starting to get a little more detail, but there's still a whole lot of light. Let's try 0.7. Still too bright. Let's try 0.6. Getting better. I'm starting to see some detail now. I do want it to look bright, but I don't want it to look so blown out you can't recognize what it is. Because if you go to the Zen garden, even at noontime with the sun beating down on it, those boards are not going to be blown out. So let's go down 0.5. 0.5 now is starting to actually look sort of like my actual boards. So let me go back here. Starting to look like that. Maybe just a little darker. I usually don't like, honestly, I don't like to go below 0.5 too much. Only because what happens if you go too low is you get this. Now it looks like that belongs in an overcast, cloudy day. Doesn't look like it belongs in this scene. So let me try 0.45. A little bit better. Maybe 0.4. I don't know. So this is 1. This is 0.45. You can see the difference in the resolution. Resolution makes a world of difference. Does that make sense? Questions? All right, so adjusting the base weight can be your friend. All right, now, any questions so far? All right, so let's talk about another simple map. This is a specular map. All right, so specular maps, get up for a second. Specular maps allow you to control more than one level of reflectivity on an object at a time. So here on this mug, normally you would expect a mug brand new, you take it out of the box, it's going to have pretty even reflectivity, right? However, use it, put fingerprints on it, water stains that have dried, you know, you put liquid in it, you drink it, it dries on the edges. It dulls down the amount of reflectivity on the object. So we've got areas like this, and they all tend to add up to just little visual details that say, this mug is older, it's in use, it's not perfect. The whole idea in CG is the computer's really good at perfect. Our job is to make stuff look like it's not perfect. I know it's kind of counterintuitive to modeling. Like modeling, they're like, get it perfect, get it perfect, get it perfect. But then you get into shading and lighting. No, it's too perfect, dirty it up, make it look worn, make it look older, make it look like it's been used. That's because that's the way we see things in the real world. So this is a black and white map. Now, normally, when you've got a surface with even reflectivity, you don't need a map, right? You just adjust the slider. That would be your base weight, or sorry, your specular weight. So you would just turn it up, turn it down. Usually we start with the weight at 1. But when you're trying to control different levels of reflectivity or specular, you want 1 to be perfectly reflective, and anything less than 1 is going to knock down that amount of reflectivity in those areas. So again, more than 1 level of reflectivity on a surface at a time. White, perfectly reflective. Black, completely non-reflective. Most of your maps are going to be somewhere in between. And on the internet, even in Substance, you can find all kinds of like, you know, water droplet stains, fingerprints, water splashes that you can utilize that are black and white maps. Fingerprints are a really big thing because as humans, we tend to put them all over the place. Pick up an object. It's going to have a little bit of oil, a little bit of residue, maybe even a little bit of dirt. From your fingers, it's going to stick to the surface. If the surface itself is sticky to begin with, well, you're going to add to it. Spec maps get plugged into specular weight. More than 1 reflective level of reflectivity at a time. Does that make sense? Question? All right, we get into roughness. Roughness is sort of the same thing. More than one level of roughness on a surface at a time. All right, so this is an old phone cover that I have. And you can see areas where it is a little bit smoother than other areas. So areas like here, smoother. Over here, keys have rubbed against the back of it. I've dropped it on concrete. I've scratched it. Had my dog pick it up in her mouth and run around the house with it. And it just gets all scratched. Now, normally you make a material, assign it to this object because this is one piece, and you've got one material property. But in order to make it look worn, you definitely need something else. So here, even on my new phone case, right here in the back, you can see there are areas, I'm trying to get it so you can see the, areas of roughness, you can see the areas of dirt. This is going to be a combination of a spec map and a roughness map. Spec map for the dirty areas, roughness for the areas that are all scratched up. Got little dents, little nicks in it. Here's a good place right here. Now you can see what happens to the reflectivity when you've got something super rough. Look how it breaks that image up compared to the rest of the surface. So here, a little bit smoother. I bring it up here. And now all of a sudden, that image gets all distorted under it. And that is roughness doing that to the surface. Does that make sense? So more than one level of roughness on a surface at a time. So they get plugged into the roughness portion of your specular. Notice we don't plug anything into the specular color. That should stay white based on your environment, unless it's metal. So again, black and white information. Black, totally smooth. White, totally rough. Your stuff is probably not going to be perfectly black or perfectly white. There is no pure black, no pure white. It's going to be different levels of gray. But you will have maps. You will make these in either Photoshop or Substance or some other application, depending on where you work, what you do. Could be using GIMP, which is a free Photoshop-ish piece of software. You could be using Corel Paint. It's, you know, whatever the place you're working at uses. All right, questions? All right, so here's an example. My old Intuos 4 a warrior, 12 years. Actually, I still have it. It still works, but not nearly as elegant as the Zen slabs. It's functional, but it's been scratched, it's been worn, it's been utilized. So this would be a combination of a whole bunch of stuff. We've got areas where there's all kinds of little dirt flecks and water droplets and other areas where you can see it's been scratched and drawn over again and again and again. So this would require all kinds of maps for this. Plus, this would require different kinds of materials. This material is different from this. This material is different from this. So you'd need at least 3, if not 4 different materials on here. So this one, these are probably all the same material. This one's going to be a little bit different. And then this one's going to be different still. So you'd need spec map to control the reflectivity on it, roughness map to control where all the scratches are. And that's the whole idea with painting in substance. You have much greater control over where everything is because you're painting in 3D. But in order to make stuff realistic, you need reference. You just don't go into substance and go, yeah, I want to dirty it up and just make it up. No, you should be using reference for everything you do. That includes your wear and tear. Questions, comments? All right, so simple height maps, bump maps. These are black and white maps also. Black will make the surface look like it's indented. White will make it look like it comes off of the surface or grows beyond it, almost like it's embossed. Whereas black will make it look like it is etched. This is illusion. We're not changing the surface at all. It's all how the surface normals display to the camera. And remember, everything's based off angle of the light, the camera, and the surface normals. So when the surface normals point away from the camera, the bump effect gets less and less. When the surface normals face the camera, the bump effect gets more and more. Now, base color, spec, roughness, they were all in fairly close proximity to each other. So remember, base color goes into the base color. Spec maps go into the specular weight. And roughness goes into the specular roughness. If you're doing glass and you want roughness on your glass, maybe it's been scratched or something, then you got to put it in the specular and into the extra roughness channel that Tony talked about when you make, say, frosted glass. And basically, when you scratch glass, you are making it harder to see through and harder to see reflections. It's sort of just like plastic. All right, but bump maps get plugged into the geometry section of the material. Geometry is the same place that we went and turned on thin-walled for window panes. There's a place called bump mapping. Click on the little checker input. That'll bring up the create render node. take a file node, because most of the time you're going to be using a file from the outside, or I should say outside of Maya. And when you do that, it will automatically create for you, and this is the nice part, automatically create a bump utility node in the network. So there are two attributes in the bump utility that you have to worry about. Well, actually just one, because if you've plugged a file into the bump, when it creates the bump utility, that file gets plugged into what's called bump value. Value is it's taking the lightness and darkness information from your file to use it as a bump map. So lightness being the whites, the brights, blacks are going to be the dark areas. So that's why it's yellow and there's an input in there. It's because that's where your file is plugged in automatically for you. Now, the thing you're worried about is this control called bump depth. That's the amount of bump or the intensity or the dominance of how it looks. Not really a good word, but it's kind of like the intensity of it, the amount. Now, by default, bump depth will be at a value of 1. 1 is always too much. It's way over the top amount of bump, which you guys will see when we do a demo. We recommend that instead of leaving it at 1, start at 0.1 instead. 0.1 is a really good place to start. And then you can go up or down from there. Now, one word of warning, the slider is a little touchy. And I would just, if I were you, just plug in the numbers you want to use. Now, here's the thing. It's at 1. If you go to 0, you turn it off. If you go negative numbers, it flips your bump effect. It's like inverting your file. So if you plug a file in and you expect your bump to go down and it's going up, that means it's reversed from what you want. So you could go back into Photoshop or back into Substance, invert it there, bring it back out, or in the bump utility, just make it a negative number. Negative numbers will reverse the direction of your bump. So like I said, if it's going up and you want it to go down, make it a negative number and it'll flip it. Black to white, white to black. Make sense? Now, every time you plug a file node in, you're going to get a file node plus this thing called a place 2D texture. Anytime you plug a file in, you're going to get this automatically. And I'll show you. I'm going to pull up my Maya scene that I've been playing around with the table. All right, so today we're going to start spending some time in the hypershade. Hypershade is basically the shading and lighting way that we interact with our networks. You guys are familiar with the graph editor from animation, right? This is sort of like our graph editor, only it's called the node editor, but it lets us see networks. It lets us see connections. So a couple of ways to get to it. I like this little cyan sphere with a little white dot. That will bring up the hypershade. You can also get to it by going up to Windows, rendering editors, hypershade there. But that's too many steps. I like to have a button, just click on it. All right, so in here, all the materials that you made in your scene will show up at the top up here in this area called the browser. Now, you'll notice in the browser section, there are a bunch of tabs. This one's for materials. There's another one for textures. And you can see those are the two textures I've played around with and made. Utilities. Every time you create a file node, you're going to get a place 2D. Remember those sampler infos and gamma corrects that we made for glass? Well, this is where they're going to be here. There's rendering. These are layers. You don't have to worry about them. Lights. It seems like a great idea, like, oh, can I graph my lights and play? No, it doesn't give you functionality in the lights. So don't get too excited. Honestly, we use it for materials, textures, and utilities the most. All right, let me start from scratch. Let me just save this and do a new blank Maya scene. All right, so new blank Maya scene, open up the hypershade. All I have is Lambert in there. I don't even have any objects. So let me just create a sphere. There we go. That sphere happens to have Lambert attached to it. So first thing we usually do when we're working on a scene is assign the AI standard surface to your geometry. So if I take this, do Shift T. Let's go to Arnold, shader, AI standard surface. So notice I created it. It's assigned to the sphere. It created a new node in materials and it graphed it for me down here. Now, if I close this and open it again, will it still be there? Yeah, probably, because it's got memory. It remembered. All right, so this area is called the node editor. This is really the hypershade. This is your browser. And here's your create. This is where you can create materials, utilities, all kinds of different nodes to plug in to Maya. Your hypershade will probably look different because you've probably got the property editor and the material viewer all here. All right, so material viewer usually is in the upper corner somewhere. And let's put the property editor underneath of it. No, under. And you got to watch because Maya is really picky about this. So this is probably what yours looks like. These two are garbage. That's why I don't have them. This is only trying to show you what the materials would look like, almost like you're rendering them, but the noise never goes away. So this is going to take up a lot of resources for you because every time you change to another material, it's going to try to display it. It's going to try to render it again. Honestly, disable it, just close it. The material viewer is just going to hog resources on your computer. Property editor, you've got the attribute editor, which honestly is a lot more reliable. And I like the space. So you'll see I've removed my material viewer and my property editor. And this is really all I care about. All right, so if you've got something down here in the node editor and you want to get rid of it, if you delete it, guess what happens to it? it goes away for good. Yeah. So don't do that unless you really want to delete it. But to clean it up here, there's a little icon that kind of looks like a little Subaru icon with 3 little stars. This will clear the graph. Just puts everything back in its little cubby hole up here. Now, if you want to get a material, say the AI standard surface, and graph it, see what it looks like if there's stuff plugged into it, all you have to do is right click on it, hover above it, right click, and choose Graph Network, straight down. This gives you a little contextual menu. So graph it. Now it's going to show up. There's all your inputs. Well, most of your inputs on the left. And then it has this thing called a shading group. That's what this little SG is on the end. Shading group is what reports to the renderer every time you hit the render button. The renderer goes, okay, shading groups, what are you assigned to? How many lights are assigned to your object? What kind of utilities or textures or nodes are plugged in? And the shading group reports all of that information. So if we were to render this out, the shading group would report, I've got a sphere attached to this, well, not attached to it, but I've got a sphere that is assigned this material. There are no lights in the scene. That's it. End of story. Now, here is the attribute editor. And if I want to plug something in, let's say I want to plug that, I want to plug a wood texture into that. So I go base, color, 2D, file. So now all of a sudden you can see that I've got a file node attached to the base color. Attached to the file node is this thing called a place 2D texture. Every time you create a file and plug it in, you're going to get this going with it. So to navigate around in this node editor, it's 2D navigation. You can pan and you can zoom, but obviously you can't rotate because it's not 3-dimensional. So it's all the usual Maya tools to zoom in and out and to pan. All right, so here's our file node. If I click on it, it will give me instant access in the attribute editor. And the nice thing about the Hypershade is I can click on the material. It'll take me there. I can click on the place 2D. I don't have to go through the file node to get to it. It's kind of like non-linear selection. I don't have to go from one thing to the next to finally get to my destination. I can jump right from A to C or C to A without going through B. All right, so color, base color, that's where this gets plugged into. And you can see the file node, it's taking whatever you plug into it. In this case, let's go get our, let's get that low res wood that we had because it's a low res object. There we go. It's at 6 on the keyboard. All right, so file node, it's plugged in there, it gives me the path. This thing plugged into the file node, the place 2D texture, this gives us some control in UV space over where this image is. So the first column over here is U, and this one is V. So you'll notice the coverage is 1 and 1. That means it's taking up the entire 0 to 1 frame. Remember UV 0 to 1, right? Okay. So translate. Now, if I want this to take up less than 1 to 1, say half of the frame, I'll put in 0.5 and put in 0.5. And you'll notice it's covering half the object. And you say, no, it's not, it's covering a quarter. Well, remember, it's half U and half V. So if you want to, by default, everything will be forced to fit the frame. So translate, this will simply move it. Like if I want to move it 0.25, it'll move a little bit, a quarter of the frame. Honestly, keep it at 0. Rotate frame, we'll simply rotate the UVs. And the downside is you can see there's where your seam is. Remember, all objects have a seam, a UV seam. So most of the time you want to aim that away from the camera, which you guys probably are aware of from modeling. So if I do it 90 degrees, now I've got a vertical texture rather than a horizontal texture. And unlike Arnold, this is actually in degrees. So 0, it's flat. 90 degrees, it's vertical. If I go 180, it's just going to flip left to right over on the other side. Now, if your texture is too large and you want it to look like tiny little boards, then we have to make it copy itself or repeat. So that's what this repeat U and V is. By default, you put a texture on an object that's going to put it on there once, actual size. But the problem is your boards might be too big for the object. Your brick might be too big for the surface. You want them to look proportionate to the scale of other objects. You don't want to have brick wall texture that looks like cinder blocks compared to the rest of the objects. So we want to make this smaller. I could type in 2 and it's going to repeat itself twice in U and then twice in V. Still too big? Now we can make it repeat again. Now, this texture happens to be seamless, which means you can't really notice where the seams are. Every time it copies itself, it makes it smaller. Does that make sense? Honestly, we don't play with coverage. We don't play with translate frame. You may rotate the frame if you're trying to make, say you have a bunch of squares and you want to make them diamonds to the camera. So you rotate it 45 degrees. That might work. But other than that, this is probably all going to remain default. The only time we mess around with stuff is usually with wrap U and wrap V, and that's only with projections. But the texture scale itself. All right, but this is the little network that we've made. Here's your material. Here's your file. That's my wood texture. That's plugged into the base color. And here is your place 2D. This is providing some UV controls to the file. And all of that's based off the UVs that are on the surface. Your texture is going to lay on your surface based on your UVs. And this will allow you to move it around a little bit inside that UV space. All right, we're going to start getting into this a little bit more with each class, each lecture. So texture mapping, this is the default mapping type that you get in Maya. Click on File node, it's going to put it on as a basic texture map using UV space. All right, so questions so far? All right, now what I'm going to do is, let me go back into Maya and let's open up the scene we were working on, which is this one. So put the wood texture on there. That's good enough for now. What I want to do is I'm going to create a sphere and sit it on top of my table. And that sphere is going to be a guinea pig to show you what spec maps, roughness maps, and bump maps look like utilizing generic Maya textures. And Maya has built-in textures sort of like Substance. Substance has got procedurals. Maya's got them also. Maya's had procedurals for 25, 30 years, but they never did anything with them. Substance came along and went, wow, we can do a lot of cool stuff with it. Let's do that. All right, so what I'm going to do is just create a simple polysphere. Pull it up out of the ground. And let's make it sit on the table. And let's scale it so it looks like it belongs on the table. So this is going to be my material guinea pig. Actually, map guinea pig. So I'm going to place a new AI standard surface on it. And what I'm going to do is, in this surface, I'm just going to take the color and make it pretty dark because it's going to be easier to see the reflectivity. All right, let's lower that roughness. There we go. All right, now, pretty simple. Right now, same level of reflectivity across the entire surface. What I'm going to do is utilize one of Maya's basic textures called a checker. You guys are probably familiar with that, use it in UVs all the time. So under base, or sorry, not base, but specular weight, I'm going to click the checker button. And I'm going to go 2D, but instead of file, I'm just going to use Maya's simple checker. Now, what that's going to do is assign the checker texture to that attribute. So when I hit the render button, everything that is white is going to be pure reflectivity. Everything that's black is going to be diffuse because it's basically turned off the specular weight. Can you see that? So the reason I like this is because I can come in and I can play around with the checker. I can make the parts that were black, white, make the parts that were white, black, and now I've just kind of flipped it. But nothing is really pure black and pure white. You've usually got levels of gray. So now we've got a sphere with two different levels of reflectivity on it. This black and white or those levels of gray are just symbolizing what maps you're painting in Substance or in Photoshop. This is what a spec map looks like and does. The amount of reflectivity. So like I said, you can just kind of reverse that. So all one level of reflectivity, and now we've got multiple levels. Does that make sense? Questions? So whether you've got a map of fingerprints or something you painted into Substance, that's what it's going to be doing. All right, now, let's take a look at my network. So one thing I didn't do was name my surface material. So let's just call this sphere. All right, so in my hypershade, there's my sphere. To graph it, I'm going to right click and choose graph network. So now my checker, notice the colors not going in to specular, it's the alpha. The alpha is being utilized as lightness and darkness information from this checker. Notice the base color has a red nodule next to it. That's because it's expecting RGB information. Roughness, specular roughness, and specular weight are looking for just black and white. And Maya knows that, so it's utilizing the alpha channel of this checker. Now, the nice thing about the hypershade is I can take this and disconnect it from the specular and then plug it into the roughness if I want to. Don't forget, if you accidentally plug a file in, you can break the connection to it. So say I plug something in accidentally to my specular weight. I didn't want to do that. Well, in the attribute editor, go to specular, and on top of the word weight, right click, and you can break connection. Now, before I do that, watch what happens inside the hypershade when I do that. So specular weight, right click, break connection. Connection is now broken. Notice it kind of left my weight halfway. So if I render this out now, let's put that back up to 1. Now I've got even specular again, even reflectivity. Now, if you want to reuse a file, you can simply take out alpha, plug it into specular roughness. And now we are utilizing those same checker patterns to control roughness. Anything that's very light is going to be super rough. Anything that is lighter is going to be less rough. So now we've got a material with two different levels of roughness on it. You can kind of see through some of the levels of roughness, but really rough, really hard to be able to see that reflection on it. So again, we're only using this checker as kind of a stand-in texture because it's easy to adjust and you can see changes. Normally, it'd be something you would paint in Substance or in Photoshop, or even utilizing a map you find off the internet. Questions? All right. Let me save this. So we've got kind of a guinea pig here. There's just the fault. There's a spec map. There's a roughness map, and you can see the difference between a specular or, you know, the amount of reflectivity and the roughness. Right, last thing I want to show you before we take a break is going to be bump maps. So to really give bump maps a fair shot, I am going to break my connection here in the specular. Specular roughness, I'm going to right click on it, break connection. And inside the hypershade, this is what I get. Now, if you want to delete these nodes, all you have to do is select them and hit delete. They're gone for good. If you forget, so let's say I clean this area up and I go, oh crap, I got that checker and I have the place 2D. I didn't want to save those. Where are they? Well, the checker's right here under textures, and the place 2D is right here. But which one is it? Fortunately, Maya has a cleanup in the hypershade that you can use. This is a little dangerous, but in the hypershade, if you go to the file menu inside the hypershade, edit inside the hypershade, you've got a command to delete unused nodes. That means anything that's not connected to an object or being used in Maya will be deleted. So now, let me go to textures. And if I delete unused nodes, it basically removed everything that's not being used in that scene. Good for cleanup, really good. So before you do your final render, you don't have a bunch of nodes laying around that Maya's got to read and say, oh, I don't need that. So here's our sphere, clean, all done. Now, we're going to plug a bump map into this beast. So bump maps, we plug into the geometry portion of the material, which is down towards the bottom. There's thin walled, which we used. here is bump mapping. Click the little checker button. And in the create render node, 2D, you can plug a file in if you've got a bump map you've made or goes with your base color. For this, I'm simply going to choose noise. Noise is going to give me almost the same sort of pattern that you guys have on your table. So I like it because it's kind of generic. And if I hit render, that's what it looks like by default. So that's what it looked like before. And now it kind of looks like a sphere that's had mud plunged into it, but didn't quite fill all the air gaps. All right, so let's graph the network and see what this looks like. So here is our sphere graph. And you'll see down here, we've got a bump utility. And it goes into something called normal camera. In the actual material, it says bump mapping, but in the hypershade, it says normal camera. So here's your bump utility. Notice bump values got something plugged into it. That is our noise from Maya. Here's the noise node itself. I'm not even going to adjust anything. And then here is the repeat. So by default, you're going to get a bump depth of 1, which is always way too much. It's too much effect. So try starting at 0.1. Looks a little better. It's not quite as deep. And remember, all of that is an illusion, all that shadow. So when I turn it back up to 1, that's really just making it darker to appear like it's deeper. Here's 0.1. Notice if I flip it in the opposite direction, here's 1, and I go -1, it just reverses black and white. So 0.1, we knock the amount of bump down a little bit. And let's go make it repeat more because noise needs to be smaller to really look good. So let's make it repeat a couple times. And let's go smaller. Smaller still. Let's go 16. All right, now, this is what it looks like without any bump. Let's go back. Take our bump. If I turn this to 0, let's fix the roughness on here because that roughness shouldn't be on. That came from me when I got rid of the roughness node in there. It left it halfway for me. So let's go to 0. There we go. So now let's go back to our bump. Turn that on to 0.1. There we go. So 0's off. 0.1. Honestly, 0.1 is always too much. Usually wind up going something like 0.02. honestly, with a bump map, less is more. You don't want to make it so it hits people over the head. All you're trying to do is get fine detail on the surface. Bump maps are for little small imperfections that you have. They're not meant to be big giant gouges or surface changes. Those are different. You either got to model those or you have to use another map called a displacement map. Right. But you can see I don't have any roughness on here. This is all bump, but you can see the bump is breaking up the reflection. So now, in addition to how, we talked about the three basic material property parts, right? How reflective is it? How rough is it? What color is it? Now, if you've got bump, you may not need to add roughness in because bump is actually acting like a roughness map. It's breaking up the reflections that you see on the surface. Let's go down even less, 0.01. Go down even lower, 0.005. And let's make it even smaller. Let's go some ridiculous number like 32. Well, no, not 332. Woo. So all we're trying to do is just make it really, really small. But you can see that it is breaking up the surface quite a bit. Got those little, really, really rough looking areas. Those are indented. The parts that are coming up off the surface that look a little smoother, those are the lighter parts of the noise. Because noise is just basically black and white and gray, all kind of mixed together. So perfectly smooth sphere. All right, let me save that. Let's stop that. All right, so perfectly smooth. Now it's got some bump on it. Questions? Everybody confused now? What's that? Yeah, it'll make a lot more sense when we actually do a couple. We're going to do the brick wall when we come back, and then we're going to make a bump map from it. But before we do that, let me just stop this. Keep it. Before we do that, let's find out why we actually need to make that brick repeatable. All right, so the files we want you guys to download are inside activity or lesson 7, 7.1 practice. So we'll come back, we'll go into a little more detail. We've got milestones for each of the lectures of stuff you should be working on. But let's go download the PowerPoint. I'm going to do that so I can have that later. Let's download the Photoshop files. And I'll take a look at the templates also. All right, but for now, the Photoshop files. So this is the brick wall source that we give you guys. We got it from basictextures.com. They were a really good website, free to use, free non-commercial, and then they went out of business. So here is the lesson. Anytime you guys are looking for textures, you're not sure if you want them or not, download them anyway. Because if you go back, that site may be down. I mean, a lot of times people create these websites. They may be a little shady as far as, oh, they verge on almost being legal, or they're really not legal. I'm not telling you to download illegal files, but people also do this with their own money. And if they're not funded, they don't have the money to continue the website, so they have to take them down. There are plenty of free non-commercial textures that you can utilize as a student. In fact, there are a bunch of free textures that you can utilize commercially. However, just remember one thing: if you're doing this for money and you utilize free textures off the internet that are totally free, you get what you pay for. They're not always going to be the great quality, because free doesn't always mean good quality. So just a word of warning. Now you'll see this has got a watermark on it. This is also not designed to repeat. How do I know? Well, take a look at the top of it and the bottom. They are not complete courses of brick. So between each layer of brick, there's always grout, right? That's what holds the bricks together, provides a really strong, solid bond. Now, the top, when we start repeating a texture, the top is going to line up with the bottom, and left is going to line up with the right. You can see left and right, they don't match. A seamless texture, you'll not be able to tell once it's on an image where the top is, where the bottom is, where the left or where the right is, because it's designed to minimize all those features. Now, what I'm going to do is, let's take this texture and pop it into our Zen Garden source folder. So let's just take this. I'm going to make a copy of it. And let's just paste it in here, replace the old one that's in there. Lecture 6, brick wall source. There we go. Let's get rid of all this other stuff too. So what I want to show you is if we take this texture and throw it on the ground in the Zen Garden, what it's going to look like by default. So let's close the hypershade. And for this, I'm going to choose basically this asphalt, the driveway. Nice big object. It's not square. That's all right. This will make for an interesting teaching. So let's just assign a new AI standard surface to it. Just going to call this default brick. So if I want to plug this in so I can see it, where am I going to plug it into? If I'm going to plug in my brick wall, where's it going into the material? So base color, yep, right here. Little checker input, it's going to bring up create render node. I want to select 2D and I want to use a file. Now, since I've put them in my source images, I should be able to find them in here. So it should be under L. There it is, Lecture 8. So if I drop it in, there you go. Gigantic. Hilariously large. So we need to make it smaller. Now, in order for me to do that, well, I have to go into the place 2D texture, and you can see it put it in once, stretched it out to fill the entire surface. So I want this to be smaller. How small? Probably even much smaller than that. Now, when you're trying to figure out scale, you really want to have reference. But even looking at this without reference, I know this is way too big for the scale of this. So let's make it smaller still. Honestly, it's still really big. Now, you can see as I'm starting to repeat it to make the scale smaller, you can notice we got some issues. So here's where the top lines up with the bottom and left lines up with the right side. So there's the left side right here. You got these ridiculous little tiny bricks. And the right, that doesn't line up at all. So it is noticeably repeating across the surface. And this is what you do not want your viewer to see. Now, granted, if you're doing like really, really old school games, you'll see stuff like this all the time. But games nowadays, they really go to a lot of trouble to minimize all this. So they either use a procedural texture, which is always meant to be repeatable and random, or they make something repeatable. Ground, stone, brick, grass, so they can reuse it. Doesn't make sense to have a huge giant texture when you can get away with a small one and just make it repeat. It's a lot more efficient to do that. All right, so this is sort of getting to the right scale that we want. Much smaller. Not happy with it, but it'll be better when we make it repeatable. And this is why we need to take this into Photoshop, make it repeatable, and then bring it back into Maya. And while we're in Photoshop, besides making a base color map, we're going to be making a bump map to get the brick height. Because bricks, the grout should look like it goes in a little bit. The bricks look like they should come out. Take a look at any brick pattern here in Full Sail and you'll see that. Except in the back lot on Bourbon Street in our Louisiana area, there's one or two little row areas that have grout actually coming out, but that's stylistic of the area. Generally, modern brick, grout goes in, bricks come out. Does that make sense? All right, questions before we take a break? Okay, so let me stop my video, stop the recording.